All right, welcome to the notes on solving multi-step equations. We'll look at 2-3 and 2-4 today. 2-4 is solving equations with a variable on each side. We're going to probably go pretty quickly through this because these are skills that we have. They just might need some sharpening. Okay, so multi-step equations, very self-explanatory here. Multi-step equations are equations that require more than one step to solve. So they're just slightly more complicated, and as we go, we'll look at more and more complicated versions of it. So here, if you look at the example, instead of just having 11x equals a number, now we have 11x minus 4 equals a number. The big thing here is, step one, you're going to want to isolate the variable. Okay, so we want to get the variable and whatever its coefficient is by itself. So I would say always step one would be isolate the variable. Okay, and then from there, once we do that, so here we added 4 to both sides. Yikes, we added 4 to both sides, and so from there, then I'm able to divide both sides by 11, and I get x equals 3. I always want to make sure I can check my answer, so I can plug this 3 back in. I can just take this right here, plug it back into the very beginning. 33 minus 4 is 29, so I did it right. Here, a little bit more complicated. Again, isolate the variable, and then, I don't know why I put 1 there, because it's really, that's the big key, okay, big key. From there, this one, we have to remember that the fraction bar is a grouping symbol. So I'm going to multiply both sides by 8 to get rid of the fraction, and then I'm going to subtract the 7. Very easy, and again, it says right here the same thing that I just said. You can always check your solutions by substituting the answer you get back into the original equation. Let's take a look at some practice. Go ahead and take a second, pause the video here, try these two on your own, and then we will check them. Try those two on your own, please. All right, hopefully you got a equals 5 and n equals negative 31. If you didn't, erase what you got. Try again, because those are the right answers. And if you still don't, make a note of that somewhere and make sure you check with me to go over that problem in class. All right, let's take a look at the next page. So, real-world examples. We have Hiroshi buying a pair of water skis that are on sale for 2/3 of the original price. After he uses a $25 gift certificate, the total cost before taxes is $115. So, 2/3 of the original price minus 25 gives us the price that he paid, but again before tax. And then we solve for that, for the variable there, and we get p. Okay, pretty self-explanatory. Let's take a look at the two examples. All right, try the CD problem and the reading problem. Try those two on your own. Pause the video, and then we'll check them. Go ahead and pause the video now. All right, so here's what I got. Here's my setup for each problem, and then the answer. Again, if you got something else, go ahead and erase it. Try again. Hopefully your setup is the same. If not, make sure you let me know, and we'll go over these in class. Consecutive integer problems, big trouble spot for students here, so I would make sure that if I were not the note-taking type that I was writing some things down here. We can do problems where we are asked to find consecutive integers, okay? What we need to know is that what consecutive means, so those are numbers in counting order. And then consecutive even and odd integers. Consecutive even integers, we take the first one, so if we have 2, and then 2 plus 2 is 4, and then 2 plus 4 is 6. So that's how we can figure out the consecutive evens. If we have consecutive odds, even though it's odd, we're still going to add 2 to it, because if I'm at 1, the next odd number is 3, and the next odd number is 5, so it's just the original plus 2, and then plus 4, and then plus 6, and so on. Number theory is the study of numbers and the relationships between them. So we're going to use number theory to work with some consecutive integer problems. So, for example, write an equation for the following problem, then solve. Students can sometimes figure this out in their head, but part of the directions say to write an equation, so this part, the original equation, is part of the answer. You gotta have it, all right? So 3 consecutive odd integers is the sum is negative 51. So here's the first odd integer, here's the second odd integer, and here's the third odd integer. All right. So we add those together, we get negative 51. We solve for n, so that's the first one. To find the other two, add 2 to it, and add 4 to it, and that gives us our 3 odd integers right here. All right. These problems can be difficult, especially if you don't practice them. So what I would like for you to do is pause the video. Only try to come up with the setup. Pause the video and come up with the setup, and then I'll walk you through how I got it. All right, so you've unpaused. three consecutive integers, not even or odd, just three consecutive. So the first one is n, okay, and it says sum, so I know we're adding. The second integer is n plus 1, and then the third integer is n plus 2, and their sum equals, their sum equals 21. Now go ahead and pause the video again, solve that, and then we'll check it. So one step at a time, I combine my like terms. I can get 3n plus 3 equals 21. Subtract 3 from both sides, and I have 3n equals 18. Divide both sides by 3, and I have n equals 6. And then I have to make sure not to stop there. My answer here is 6, 7, and 8. If you don't give me the three integers, okay, if you leave this part out, and you only give me this over here, you won't get full credit. You've got to give me all three integers. Those are all kind of things that I would write down if I were taking notes right now. Okay, so that's it for 2.3. Let's look at some stuff from 2.4. 2.4 is solving equations with variables on each side. Okay, the only thing that makes this hard is that we've got to follow some distinct steps. Earlier, we talked about how we wanted to isolate the variable with the problems we just did. Here, the first thing we have to do is we have to get the variables on one side. That's the very first thing you want to do. So if you'll notice here in the example, I have 2 plus 5k equals 3k minus 6. I want variables on one side and constants on the other. Okay, that's what I'm trying to do. So we subtract 3k from both sides. All right, well now I only have a variable over here. Then I have to isolate the variable. All right, well now I have variables here and constants here, and I'm ready to solve. I can plug my -4 back into the original and see that I'm correct. No problem. Go ahead and take a second, get some answers for A, B, C, and D. Pause the video now, take a second, get some answers, and then we will go over them. All right, so here's the answers I got. I got W equals 1.5, X equals -28. A equals 1/3, and C equals -1.4. The one point I will make is that the only time it's okay to have a decimal in my answer is when a decimal is in the problem, unless the directions say so. So no decimals in the problem, like in 1B and 1A, that means fraction answers. Okay? If you're ever not sure, ask. But usually that's a good rule to go by. No decimals in the problem means no decimals in the answer. All right, then we don't get in trouble with rounding, and we're going to have to be comfortable with fractions all year, so it's good practice for us. If you didn't get these, go ahead and try again. Okay, if you didn't get them the second time, make sure you make note of it somewhere so we can go over those problems in class. So now we're going to look at with grouping symbols. We're pretty comfortable with the distributive property here. So that's what we're going to use. We're going to use the distributive property to get rid of these grouping symbols, and then we're going to try and get variables on one side, constants on the other. Same idea, just adding grouping symbols into it. I'll go ahead and walk you through the first step of 2A, and then you're going to do the rest on your own. So at first, I would do nothing with this. I think this is a good habit to be in to work my way down the problem. Okay, working down. More students are successful when they work down. So that's 8s minus 10 equals 18 minus 6s. Okay, now the next thing I want to do is I'm going to add 6s to both sides, and then I'm going to add 10 to both sides at the same exact time. As long as I do it to both sides. Sometimes students do well when we take this equal sign and we put a line down the middle like that. So then you know whatever's on the left of the equal sign, or of the purple line, I have to do the same thing on the right. So 8s plus 6s is 14s. Negative 10 plus 10 is 0, so we don't write it. 14s equals 18 plus 10 is 28. Negative 6s plus 6s is 0. So then divide both sides by 14, and we get s equals 2. You go ahead and pause the video right here, see if you can get 2b by yourself. Go ahead and pause the video now. All right, we're back. Hopefully for 2b, you got n equals 1/9. If you didn't, try again. If you still don't, let me know. We'll go over that one in class. There are some special situations, some special solutions that we get sometimes, and they're really simple. If you are solving an equation and you get to a point where you get an untrue statement, the answer here is no solution. Okay? Don't put this, don't put NA, don't put no. All those are bad answers. Okay? Don't do any of those things. Okay? Bad, bad, bad. Don't do those. All right? Simply don't do those. Simply write no solution. Okay? Down here, if you are solving a problem and you get the same exact thing on both sides, Okay, to the point that it's a totally true equation. You can get 0 equals 0. Okay, this means this equation is what's called an identity. An identity, so your answers here, this is where we do have multiple answers actually. I would accept identity. What it means is that no matter what value we pick for the variable, it'll work. I would accept all real numbers. And I would accept infinitely many solutions. And you probably need to be comfortable with all three of those, because depending on where your question comes from, that might be asked a different way on the SAT, on the PSAT, on the SOL, so you need to be comfortable with all three of those. Go ahead and pause the video real quick right here. See if you can tell me which 3A and 3B are. 3A and 3B. One of those is an identity. One of those is a no solution. Pause the video, try those, and let me know what you get. All right, you've unpaused. I got all real numbers here, and I got no solution here. Make sure you're getting the same thing I am. If you're not getting those, again, try them again, and if you're still not getting them, we'll go over them in class. Big key concept summary, big things I would write down. I would make sure that every time I'm doing a problem, I'm simplifying each expression on each side, okay? That's distribution, that's whatever, combining like terms, anything I can do on each side of the equation, okay? Once I've done all of that, the next thing I'm going to do is I'm going to use addition or subtraction properties to get variables on one side and numbers without variables on the other, and then I'm going to use multiplication or division to solve. These three steps I would want to make sure that I knew and understood, because that is how we do this. There are many situations in which we have variables on both sides of an equation. So here, for example, find the value of x so that the figures have the same area. So we need a setup here. Your setup is 10x, because that's a square. And then a rectangle. This is 6 times 3 plus x. So we do this. We solve. You end up getting an answer here as b. Okay? Let's try one on your own. Down here. Find the value of x so that the figures have the same perimeter. Go ahead and do that one now. Pause the video. Try that on your own now. All right, you've unpaused. Hopefully you got G. That is the correct answer there. If you didn't, let me know. We'll go over these in class. Do me a favor. Try some problems, okay? You don't have to do them all. Try some. Find some hard ones that you want to ask questions on. These are from both of these sections. We'll have a quick check on this stuff when you get to class next time, so you're going to want to have some familiarity with these questions. These 10, these 9. You don't have to do them all, but do some. See you next time. Bye.